chapter, it was called row echelon form. You're supposed to take the first two, get rid of the x's, take the second two, get rid of the x's, take those two, get rid of the y's. Have your stair step, go back and plug in, row echelon form. The math was called Gaussian elimination from Gauss. He's a mathematician, did a lot more than just math, but that's okay. Gaussian elimination. That was the system that was being followed. The problem is you still need back substitution. Now we went ahead and did that with this one. We got it into REF form. We solved for our x, our y, and our z. We figured out that the program in our calculator does not choose the first equation to be first for row echelon form. It chooses the last equation and has to divide everything by that leading coefficient, whatever it is, to make sure that it's 1. Then it goes ahead and uses the second, it uses the second solution, or the solution of the second set of equations that are solved for y and z to be the second one. And then last but not least, it puts the z as the third one. But either way, we both ended up with the same answer. Woo! But there's a better way. Maybe not a better way. There is a further way of continuing to simplify until. Continuing to simplify until. Not just getting the leading coefficients of 1s, but also getting the rest to be zeros and then being done. So what we've done is we've gotten it so where we've gotten the main diagonal of 1s, all the bottom elements are zeros, aka like the y, the x term in the second equation is canceled and the third equation is canceled. The y term in the third equation is canceled. We've gotten the leading coefficient of 1s and zeros below, but what we've done is left this equation with numbers and then had to back substitute. But if we could persevere, if we could keep going, and if we were programming, if we could keep programming and figure out the correct order of operations as far as how to tackle the matrix, and if we could get a leading coefficient being diagonal of 1s, little people, zeros everywhere else, we would end up with our final solutions of x and y. For instance, if I was to take any sort of system from last chapter, let's see, we did ones with elimination, we did ones with substitution, we did ones that were three-dimensional with 3 equations, had to use REF to solve. If I were to give you any one of those systems, at this point, there is an operation in your calculator, RREF, reduced row echelon form, that, if possible, will take that system all the way to the 1s and the zeros, and then on the right-hand side will be the solutions. Didn't we do that yesterday with this guy? Remind me.
Yeah.
Okay. And we saw that if we could get the identity matrix, all the 1s, zeros above, zeros below, 7, 2, 2 pops up. Now, does it magically pop up? No. Someone took a lot of work to program the system into your calculator, but the system is called not just Gaussian elimination, but Gauss-Jordan elimination. It means basically going all the way to that identity matrix. Going all the way to that identity matrix. Once again, trying to find a system. A systematic approach. So it's not, okay, give me a problem, and then in that moment I'll try to figure out the easiest way to do that problem and do it. It's like, no, give me any problem, and I will follow steps A and B and C and D and have an answer if it's possible. So what's the difference between Gauss-Jordan elimination and Gaussian elimination, besides the fact the answer? Well, let's do one. Look at this guy. You guys better be ready. I hit the wrong button, we just gotta wait for a second. Let's get the system down, written down by hand. Trying to learn the system that had to be programmed in the calculator. Trying to learn the system that had to be programmed in the calculator. I keep hitting the wrong button. Stop, stop, stop. Okay, a couple more seconds for you guys to get it down. As we saw yesterday, if we follow the matrix operations, we don't keep all the x's, y's, and z's. And if you want to, use it for that, or think of it in a specific purpose. It takes less time to write down numbers than numbers with letters, right? Do you see all the x's are the first column, then y's, then z's, then w's? Then constants? The first name of the game is copying it down correctly up otherwise we'll be in some trouble. Leave this off until the end. The augmented matrix would say put a little dotted line right here to keep us honest, right? These are all of our coefficients. We would call this the variable side of the matrix, and that would be the solution side, or the constant side of the matrix. Okay. Just for sake of simplicity, since we are humans, make this a little bit nicer on ourselves. Guys, in row echelon form or even reduced row echelon form, what number do we want in this spot right here? Wouldn't it be super nice if we could just switch those two?
You can.
Our calculator would call it row swap. In our notes it said that it was legal to interchange two rows. I'm going to go ahead and interchange those two rows to have that nice one already waiting. Some of you might want to look at this. In order to get this to be a 1, a calculator would do it just fine. Divide everybody by 3 and go from there. By hand now, we don't want to divide everybody by 3 if we don't have to. So I'm going to move that 3x plus 2y minus a plus w equals 0 row right down here to the second spot. I'm going to move this one. We'll go check the air. So is that first element looking a little bit better now? Hopefully. Now, here's the system. Here's the system. The system says if you're trying to get reduced row echelon form, the correct process to go is to establish in each column, starting on the far left column, to establish the 1 first, which we just did by swapping. To establish the 1 first and then get the zeros to finish off the column. We work column by column to get our identity matrix to get towards that final end of I want my x, my y, my z, and my w right there ready for me to go. The problem is our 1 is set. Our 3 and -2 and 1 don't belong. The nice thing is though, whenever you set the 1 in a column, we can use that row, multiplying that row by the opposite of every coefficient in the other rows, and then adding it one at a time. Meaning, what if I was to take -3 row 1 plus row 2 into row 2? Why would that be helpful? -3 plus 3 is 0. Now you have to do that for every single entry, every single element in each row, but that will cancel out to get a 0. What do you think we're going to do for row 3? 2 times row 1 plus row 3 into row 3. So every time, you just think, a systematic approach, oh, no big deal, just take this coefficient, multiply the 1 by the opposite or negative of the coefficient, and then add each of the entries, and then you got it. So then this one would be -1, row 1, plus row 4 into row 3. We warmed up on that mental math, kiddos, for this very reason. It's time for us to go. What's going to stay the same? What's the one part that I'm not changing?
The first row.
Good. So you can rewrite that. 1, -1, 4, 2, and 25. The second row. Gotta be careful. You ready? -3 times 1, -3. -3 plus 3?
0.
0. That's the easy one. Okay. -3 times -1, +3. +3 plus 2 is?
5.
Okay. Now you guys keep going, and then double check my work. Believe me. Someone to double check is going to be really nice on these. So you go ahead, get a little bit ahead of me, and I'm coming behind. Double check my row. 0, 5, -13, -5, -75.
Yep.
We okay?
Yep.
Third row. You guys get a little bit ahead of me. Maybe you already are. Perfect. Keep going. 0, negative 1, 10, 3, 52. I'll just change yours. Double check mine. Anybody there yet?
Yeah, I got the same.
Fourth row, get a little bit ahead of me. Fourth row, 0, 2, negative 3, negative 1, negative 19.
Yeah.
Cool. What did I just establish? What did I just finish? My first column. That wasn't too bad, right? What's next?
Get rid of the 5.
R plus.
Second column. And as Jonathan was just saying, get rid of the 5, he realizes I said the first step in every column is to establish the 1. So where should the 1 be in the second column?
At the 5.
What can we do? Because we're humans and not computers.
Switch.
We could multiply everybody by 5, because we can't add anything, because we need the 0 to stay the same. As soon as I start adding, I might mess them up. I have to divide by 5, divide by 5. It'd be almost nice, but he's gross. So, do you want to swap it and make that 1 nice and easy to get? Okay, then let's swap. Swap and multiply by a negative, I like it. So let's put row, let's see, how would I put that? We'll do
Row 2.
negative row 3, swapped with row 2. Is that okay? Negative row 3 swapped with row 2. Since we're humans, we can kind of play with it a little bit. So row 1 staying the same. He's good. Row 4 is staying the same. 0, 2, negative 3, negative 1, negative 1. Row 3 is going into row 2 and being the opposite sign. So 0, positive 1, negative 10, negative 3, negative 52. And then row 2 is going into row 3 spot. So 0, 5. You guys agree? Cool. Did we establish the 1? And the answer is? Did I not switch it? Oh, remember we're only multiplying this guy by negative, this guy is keeping the same. Alright, can you guys tell me, based on what we did up here, once we had the 1 established needed zeros, what are we going to do next?
Negative 2. Row 1 by 5.
Negative 5.
Not row 1 by 5. Okay, negative 5 R2 plus R3 is what Patricia's saying, and I totally agree, into R3. Is that good? Negative 5 times this guy plus that guy, perfect.
That's a part.
Negative 2, I think, Dean, you're saying this one, right? Negative, oh, okay.
Negative 2 row 2 plus row
Negative
4.
2 row 2 plus row 4. However, we don't just want REF, we want RREF. We don't just want those zeros, we also want that to be a 0. So we want the identity matrix, all ones, zeros above, zeros below. So what am I going to do with this guy also? Yeah, row 2, which would be a positive 1 times row 2, plus row 1 into row. Because I want zeros above and below, that's my Gauss-Jordan elimination. Remember when we did this in our calculator yesterday, to get the 7 to 2, we needed 1s and zeros below and above. Does that make sense? Kind of? Whew. Don't worry, there are only a couple blank hands on calculators. But I do have a kid taking linear algebra right now, and she's like, oh, the first test was so easy, we were just doing basic stuff that you learned with kids. Well, that should learn about. Okay, here we go. What row is staying the same? Second row, right?
Yes.
You guys get ahead of me, you can double check. Let's start with the first row. See what this one? First row, 1, 0, -6, -1, -27. Double check me, I did it fast. 0, 0, 37, 10, and 185. -5 times -3 is a positive 15 minus 10. And then this one was 260 minus 74. $91. I think 0, 0, 17, 5, and 91. Anybody got? Second row? Sorry, no. Second column is establish. No. You know what to do, you just don't want to do it. What do we need to get now? And the only way, just listen carefully, the only way to get a 1, which you can make your computer do, remember, we're learning the system in order to think through, hey, I could have programmed this if I could learn all the code. Coming on down, the only way to get this to be a 1 without messing up all of these, because as soon as I start adding, I'm going to mess up everybody with the zeros. The only way to make this a 1 is to divide. 5? So I'm going to do 1 over 37, row 3 into row 3. Now, I'm being a little bit nice, just a little bit. We would have to rewrite this whole thing, just I'm trying to make it not look disgusting. Can we go ahead and make that change right now? What's 1 over 37, 0? 0. 0. 37 over 37? 1. Careful. Careful. This is a very dangerous thing to do since we're all doing it together. You guys are double checking me. I'm going for it. 10 over 37 does not reduce. Is anybody trying 185 over 37 to see if it does?
I think it, yeah. That'd be a problem.
Yeah.
Just 5?
Just 5.
Oh, sorry, I forgot it was 37. Okay, so one nasty fraction, but it could have been worse, right? Whew. We've established our 1. Now, turn the 17 and the -10 and the -6 all into zeros. How do we do that? We multiply this third row with the established 1 by the opposite of all of these coefficients, right? And then add. So for instance, what's the first one going to be?
Positive 6 row.
Good. 6 row 3 plus row 1 into row 1. What's the second one going to be? You can do the opposite, right? Good. 10 row 3 plus row 2 into row 1. What's the last one going to be?
Yeah.
Negative, right? Negative 17 row 3 plus row 4 into row 4.
Are we going to get 6 into the first one then?
Huh?
Are we going to get 6 into the first number instead of
Nope, because anything times 0 will keep the identity. Because 6 times 0 plus 1 is just 1. 6 times 0 plus 0,
Oh.
Yeah, that's why I have to do it in this order. If I did it in any other order, like if I went for the zeros then the ones, it would all get messed up every time I do something. But by establishing the ones then the zeros, and following the strict, like, hey, multiply the established one by the opposite and add, these will be preserved. And that's good. What row stays the same?
Are you putting two things into row one?
Oh, did I? This should be row 2. Thank you, thank you, thank you. And that looks like 21.
Series.
Oh, I just meant like my rewriting, and I just erased it. But I feel you. Alright, I'm coming down. You guys going ahead of me? 6 times 0 plus 1 is 1. Yay! Okay, keep going.
Oh.
It's nice until the next one. Hey guys, wait a minute. How am I supposed to? Okay, 6 times 10 over 37 is 60 over 37, right? Can't I make -1 negative 37 over 37?
Yes.
Oh, okay, good. So 60 minus 37 all over 37. That's not too bad. 60 minus 37 is 23. Okay. And then, oh, this one's easy. 30 minus 27 is just 3. Anybody back me up? 1, 0, 0, 23, 37 from 3.
Yes.
Second row. 0, 1, 0. So close. 10 times 10 over 30 is 100 over 37. Minus 3 changed into 37, so it would be 90, 111, 37, 111 minus 100.
This is ridiculous.
111 would be, I think, negative 11 37s. Anyone there?
What?
That was beyond me.
Well, hold on. 10 over 1 times 10 over 37 is 100 over 37, right?
Yeah.
Then I need to get this into 37s like I did there. So I multiplied this by 37 over 37,
She's 127.
which is, I think it's 1, isn't it 111?
Yeah, so
It says 21, carry the 2, so 111. And 111, take away 100, is 11, but I realized that this one was bigger and it was negative, so it's negative 11. There you go. And then 50 minus 52 is negative 2. There we go. Okay, 0, 0, 17. Okay, so that'd be negative 170 over 37. That 10 is actually quite nice, even though you don't like them. Worst comes to worst, off to the side, negative 170 over 37 plus 5 times 37 over 37 would be
we just added.
150, 185, right?
Yeah.
185 over 37. That'd be 15 over 37, anybody beat me there? Cool. And then, what am I multiplying? Oh, 17. Oh, hi, I don't want you. The rest of them. 5 would be 50, 85, negative 85, 76. Anybody there? I'm hearing yeses. Hopefully you guys are backing me up, yeah. Well, I assume some of you are just like, yeah, let's go. Okay, anyway. What do I need? Multiply by a reciprocal. Wait, guys, look, if I multiply by a reciprocal, maybe all of you will cancel out.
Yeah, guys.
Okay, so multiply row 4 by 37 over 15. Row 4 into row 4. Okay, 37 over 15. You guys, we're going to do this carefully all together, not make a mistake, right? I'm about to erase something. You can't go back and see what was there before. That would just be a 1, right?
Yes.
Okay. And then what's 16 times 37 over... Wait. 6 and 15, that reduces, right? Not nicely, but at least somewhat. So 3 goes into 6 2 times, 3 goes into this 5 times, 2 fifths times 37, so that's going to be 74 fifths. Someone double check me.
Yeah.
Yeah, we're good? Have I established my 1? And the answer is yes. Now remember, with technology, the system is nice and all, but if we could program it for a calculator to do, how fast can it do these calculations we're doing? So much faster and so much more efficiently and hopefully accurately. These days, it should be accurate. Okay. What's my system say? How do I finish?
I think there was, do the opposite.
Do the opposite. Do the opposite and then add, right? So, I have my row 4 is my established, so the first one's going to be negative 23/37 times row 4 plus row 1. I'm just not going to show that into row 1, I'm running out of room. Second one's going to be positive 11/37 row 4 plus row 2. Then negative 10/37 row 4 plus row 3. You guys feel like you're getting the system down. The numbers are gross, but the system, you're getting into it. Which one?
74.
Remember, reciprocal is to get a 1. Remember, now we need to get zeros, so we need to multiply this guy by the opposite and then add. So negative 23/37 will cancel and get me 0. Does that make sense?
Yep.
Colby, go ahead.
So we're gonna have to, on the test, do this with our heads.
Hold on, Colin. Do we need the fraction of what we was asking?
So it's gonna,
Yeah.
we have to multiply
There's
7.
a non-calculator portion and calculator portion. The non-calculator has one long answer, the rest are multiple choice.
That's the form.
There's only 1 or 2 that are this big on the test. That are this big. Other ones will be more like a 3x4 or a 2x3 that you can
So we're gonna have to do 74 times 20.
Okay. I said the fractions might not be as bad. Goodness gracious. 0. Yeah, it's gonna be a piece of paper, right? Thanks, David. Go team. Okay, the fourth row is established. Guess what's really nice? The way that we set up our system, none of these guys get messed up. Okay. Okay, I'm gonna get 0, 0, 0. That's not the hard part. What's the hard part?
Everything.
No, just the last ones. Okay.
4 times 3.
But pause. Negative 23/37 times 74/5. Doesn't 37 and 74, don't they reduce? What's 37 in the denominator, 74 up top? That's just going to be 1 and 2. So 2 times negative 23 is negative 46 fifths. And that's going to happen with every single one, because now that we go down to the next one, 11/37, the 37 and the 74 reduced to 1 and 2 again, so now it's just 22 fifths. And then 10 and 37, so 37 and 74 reduce again, that's just going to be negative 20. Hey wait, negative 25ths, isn't that a nice number? This one didn't come out so good. It was a negative or positive? It was a positive. 22 fifths, right? It was a lot of numbers. But at the end of the day, depending on the year, sometimes we have it right and you guys double checked me well, and sometimes we have it wrong and you double checked me poorly. Either way, at the end of the day, our hypothesis for this solution is the following. It's a 4-dimensional graph. It's a very good question. You have to go a little bit deeper in math to get there. That is more than 3 dimensions. Kudos! You know how to put this in your calculator. Some of you have been wanting to do it the whole time. Go! Second, reciprocal button. Put this whole matrix in your calculator. And then go do RREF and let's see if we got it.
Don't put your shit
I'm going to Dora the Explorer as it goes.
Let's go Diego, go.
Thank you.
John Mario assistance.
Swiper, no swiping. Anyway.
Does it matter if you switch one of the equations?
No, it doesn't matter if we switched. You can start with the very original one. Because remember, once you get down to the identity matrix, the calculator might have gone a harder way as far as calculations, but hey, it's a computer, who cares, right? So I'm going to go ahead and start with the original, because could we have written something wrong? And the answer is yes. So I wouldn't want to use anything but the original problem when plugging in. Yeah, RREF. Calculator's going to do decimals, right?
Yeah.
Second matrix, you have to go to math, RREF. I think it's B, right?
I got it. I got it from positive.
Yeah, I
I
got
put it in wrong, buddy. Oh, you got it also. Yeah, what is
Double check. Did we all type in? Do you guys do the same thing I did?
Yes.
Now, can I tell you something about coding and programming? Even though there is a way to tell a calculator how to do this system, what we're going to face right this second is very common in programming classes because you're like, oh, I did it all right, I did it all right, I did it all right. And then there's this little operation on a lot of programming languages where it's like, hey, let's run the code. Guess what very frequently happens when you go to run the code?
Doesn't work.
Doesn't work the way it's supposed to, or it doesn't work at all. And what do you have to go through?
All the
All the lines of code to find the mistake. It's very tedious. It can be very painful. So even though calculators are cool, and even though there is great benefit in having a systematic approach and understanding the system and then telling the computer how to do it, that idea even of programming, you're like, oh, okay, well, I'll just program it and have it do all my hard problems for me. The coding can have you face the very same step that we're going to do right now. What happened? You guys were double checking every single step, right?
Mm-hmm.
Wait, I couldn't know one part. Or something. I seem to remember.
Okay. I made it sound real good. I always do. I didn't make a mistake on purpose, but it always happened. Not always. There were a few years that we got it wrong. But question. Let's first check all the coefficients. Because if you guys copy my coefficients and not the problems, we'd be in trouble. Are we allowed to row swap? We're totally allowed to row swap. That's not a problem. Just making sure everything's written down correctly and I have it. That's why I'm coding also they're usually teams. And they're editors of code, not just developers anyway. I think all the coefficients are good. You guys agree? Okay, your coefficients are good, my coefficients are good. The one is established. Now we gotta double check all of our math.
I think I found a mistake.
Yeah? Where'd you find it?
Is this? Don't look at me. I don't know how to say it, but like, you did the math wrong.
No, that's okay, but tell me where. Are we dealing with the first column, second column, third column, fourth column?
The fourth column.
Fourth column.
No, I mean, the fifth column or something.
Fifth column? The very, very end?
Is that one? What was the 91?
Oh, because that one was gorgeous, huh?
And go up.
Right here?
I think that should have been in 85.
Right
We're
here?
doing 101. Yeah, we're.
So, okay, hold on. Do you guys see what I'm doing? He's saying that he thinks this one went wrong. And so this one, I'll go back to the previous step and say where the 91 came where did it come from? -2 times negative, oh yeah. Yeah, nicely done. I did 114, I think, instead of 104. So 104 minus 19, took away 4 and 15. That would be an 85.
I should have told you that a while ago. Like, did
Did you see that a while ago? Kevin.
honestly.
That's why you don't say yes when
That's okay, but now he knows. Be strong, be confident. Let us know if something's not looking good.
Let's jump.
No, no.
You're literally wasting engineer's time.
Calm down, calm down.
whoever's watching this video.
So wait, pause. I still need the -17, right? Okay, that's fine.
So I'm just down here, negative 17 times 5 is negative 85. Negative 85 plus 85 is 0. So that last element should be a 0 now, right? Now, why does that make everything amazing?
Negative 5 to 5.
When I multiply 37 over 15 by 0, it stays 0. And what's so cool when we go to this final column? When we multiply everything by a negative 23 37ths and 11 37ths and a negative 10 37ths, does it even matter if I'm just multiplying it by 0? What happens to all of these guys? 3, negative 2, 5. We were lucky that that was right there at the end. Yes. Do you guys ever get to towards the end of something and then just kind of like, here's a half effort and then mistakes happen?
Wait,
Why
why
must it?
why don't you have to?
Because when we multiply to cancel, and we multiply, oh, it's 0. Oh, okay. 0 plus 3 is 3. When we multiply to cancel, when we multiply, oh, it's 0. 0 minus 2 is negative 2. When we, well, I mean, we have to do them there. We have to do them there, right? What do we end up with? Guys, you have it in your calculator. Now, how does it look?
And what's the same?
What you guys think, Kevin?
Thanks, Kevin.
Why did you say anything earlier?
Okay, what is this called? Gauss-Jordan elimination. Well, in homework, you're going to be able to have fun with your calculator. Take your time. But tomorrow when you come in and your group start checking homework, you might want to kind of, let's look line by line. Let's look line by line. Now, kiddos, are all of them this nasty?
You just gave us a
No. Pause. Look at the backboard. I have this homework due tomorrow. It's going to be due Friday instead because we do have a few more examples and things I want to look at, I think. Yeah, do I have a few more things to look at? Okay. So we have the idea. However, this won't be due until Friday. Now, pause. Did you guys already write down the homework?
Yes.
Cool. I need one person from every group to go up and get a task correction paper for everyone in here. I'm going to do it. You guys will start this homework, but you won't finish it. Aw, then we can get ahead some other ways. So we're not hard today. Don't worry, I'll give you guys
Yeah, if there's anyone you should,
They're already in my web. They are?
Wait, which one?
7.
Alright, check it right now.
Are they gonna be part of this reading period?
Yep, they're already in there. Why did I do it? Because it helps most of your grades.
Oh, yeah.
Most. Yeah.
Why did you literally look at every single one, but the entire class average went up from me putting it in this grade? Jacob, Colby, you work on corrections tonight, not due tomorrow, but due soon. Colby. Toby. John, I just need everyone that's here come up. John, Patricia. Jamel. Thomas.
Yeah.
Ryan. Sorry, Ryan Nix. Rebecca. Victor. Andrew. Caroline. Kevin. Joseph. Dean. Remember, correct everything, including the bonus on this one. I'm not giving you this one. Caro. Melanie. Ryan. David. Go through and find your corrections. You should have too many to do. If you guys can bust these out tonight, juniors have more homework later. Alright, work on, start on 8.1, go until you get stuck. Tomorrow we will finish 8.1. Sound good? P.S. If you dare just use your calculator on this homework, I will take off double points extra. I'm not saying no calculator. If they say you're allowed to use it, then yes. If you want to check your work, yes. But you're going by hand. It's part of how life goes. If you're interested in computer science, this is part of what you got to do. Maybe not this specifically, but the idea of trying, following a system, making a mistake, and going back and finding it. reading and math. All right, cool kids. Are we good?
See, I didn't.
Juniors, we'll catch you on the other side.
When were we allowed to?